October 13th, 2020 practice. Dominic is stocking bathrooms at the hotel where he works. So he has 15 rolls of toilet paper and 18 soaps. If he wants all the bathrooms to be stocked identically with the same combination of supplies in each one and nothing left over, what is the greatest number of bathrooms Dominic can stock? So, what we're going to do, let's take a look. So he wants them to be stocked identically, which I get it because you don't want one room to have more than another room, and then you'll have people complaining. So he wants them to be the same, with the same combination of one with nothing left over, so no leftovers. So that's also important because obviously he would want to use them all. So what's the greatest number of bathrooms that he can stock? Greatest common factor! But now what are we going to find the greatest common factor of? Well, 15 rolls of toilet paper he has. And then he has 18 soaps. Let's do green. All right, so we're going to find our GCF, or greatest common factor, of 15 and 18. So we're going to have 15, and then we'll have 18. So let's find our greatest common factor. Let's see. What can we break down 15 and do? What times what is 15? What times what is 15? Oh! Let's see. So this one we have 5 times 3, or 3 times 5 equals 15. 3 times 5 or 5 times 3. Are either of those a prime number? Yeah! 3 is a prime number because the only two factors are 1 in itself. Same thing with 5. It's a prime number because the only two factors are 1 in itself. What about, so now we can do our prime factorization of 15. In order from least to greatest, we have 3 times 5. What about 18? What times what equals 18? This one you can do it a couple different ways. You can do 9 times 2, or you can do 6 times 3. Let's do 6 times 3. 6 times 3. All right, now, are either of those a prime number? Yeah, 3 is a prime number because the only two factors are 1 in itself. What about 6? No, that's a composite number because we can break it down. We can break it down on the dance floor. All right, what times what equals 6? 3 times 2, or 2 times 3. Great job. Now, we can circle these because both of them are a prime number because the only two factors are 1 in itself. So in order from least to greatest, we have a 2, a 3, and another 3. Remember, we are multiplying these. Now, what do they share? So they share. Do they share a 2? No. What about a 3? Yeah, they share a 3. Let's highlight that. What about another 3? No. Do they share a 5? No. So what prime factors do they share? Oh, only a 3. So we don't even need to multiply them. Our greatest common factor is 3. Now, 3 what? Well, that's the number of bathrooms. 3 bathrooms. Now, here's a tricky one. How many rolls of toilet paper and how many soaps can he put in each bathroom? Well, if you take each of these numbers and divide it by the greatest common factor, you will get how many rolls of toilet paper and soaps. So 15 rolls of toilet paper, he's dividing that into 3 bathrooms. 15 divided by 3 is going to be 5. So 5 rolls of toilet paper. And then, what else do you think he's going to have? So 18 soaps. Well, if we divide 18 soaps divided by those 3 bathrooms, we get 6 soaps. We can actually do that. So 3 bathrooms, they'll each have 5 rolls of toilet paper and 6 soaps in each. So that is going to be our answer, and then we extended it a little bit. Awesome job.